Welcome students to this series of lecture on LangGraph. And in this series of lecture on LangGraph, till now, we have understood how to build a multi-agent system, how to build an intelligent workflow, how to design an agent orchestration. But now, in this lecture, we're going to explore about one of the most powerful capabilities of LangGraph, that is persistence. And I would say this very clearly. Persistence is one of the most game changing capabilities in LangGraph. Now, yes, LangChain also provides some level of persistence like memory, vector stores, caching. But in comparison to LangChain, LangGraph provides workflow production level persistence, which is far more powerful and production ready. And that is why persistence becomes extremely important in LangGraph. I also sometimes say that persistence is the mother of many capabilities in LangGraph. You say human in the loop. You say human in the loop. It is because of persistence. You say break and resume. It is because of persistence. You say error recovery. It is because of persistence. You say debugging workflows. It is because of persistence. You say replay execution. It is because of persistence. So if you understand persistence in LangGraph, you understand automatically many other capabilities of LangGraph, like human in loop or error recovery, because those capabilities are actually a byproduct of persistence. Okay. So, what is persistence? So, technically, persistence is the ability to store. Number one, ability to store. Number two, ability to resume the state of your workflow. And number three, the ability to store and resume the state of your workflow for the right session, for the right user, and the right time. So, it is the ability to store, resume the state of your workflow for right user, session, and time. That is what persistence is. But still, this definition sounds technical. I understand that. So let's simplify it. Persistence means that your workflow, your process can pause, can stop, can break, and also resume without losing previous conversation, without losing workflow state and progress, without losing state of execution, and without losing context of decision. That is persistence. Assume you have a very complex workflow, and whenever the workflow becomes lengthy, complex, and sophisticated, we typically use LangGraph instead of LangChain. We know that. So assume there are multiple steps in your workflow. Say step one, which is data collection, step two, which is pre-processing, step three, something, step four, analysis, step five, report, whatever. Now, what happens? Step one executes successfully. Step two executes successfully. Now, while moving to step three, system crashes. Now, what happens? If persistence is not there, you lose step one output, you lose step two output, you lose your complete workflow progress. And you have no option and you have to only restart from step one. You don't want that in production system. But if persistence is there, LangGraph already stored step one output, step two output, and all the workflow state. When you restart and resume, you directly start from step three because all the information that is needed is there. And the system and the workflow also is aware that you have to start from step three, not step two. That is persistence, and that is the power of persistence. So, the question is, why do we need persistence? In a production system, failures happens. It could be a system failure. It could be a simple API failure for which you are not responsible. That is an external API, model failure, human interruption, network failure. There are different reasons for which a system or a process or a workflow stops. Without persistence, workflow breaks and you cannot resume from where it broke. With persistence, you can resume from the point where it paused, where it break, right? And that's why you need persistence. And that is why persistence is critical for any production grade AI system. And that's why everyone is moving away from LangChain to LangGraph because LangGraph is the framework for AI agent, which is production ready framework. Now, I generally say that LangGraph is not powerful because you can use agents or AI LLM models. LangGraph is powerful because of this capability, persistence. You can use LLM AI agents even in LangChain and other framework. But what makes LangGraph stands out in all the framework is one of the capability that is persistence. Okay. And because of that, agent becomes scalable and useful. Human in loop becomes possible. Break and resume becomes possible only because persistence exists in LangGraph. This is the architectural advantage of LangGraph. This is one capability which is the advantage of LangGraph. I cannot emphasize more than this. Now, this is about benefit of persistence in LangGraph. But technically, what creates persistence? Persistence comes from two core ingredients and one optional ingredient. Okay. The core ingredient is state. We discussed about the state and the checkpointers. We never discussed about the checkpointers. And the optional one, but important ingredient, if you have multiple sessions, multiple user, is thread ID. Is thread ID. Okay. So persistence technically is state, checkpointers, and thread ID for multiple sessions. That is how you create persistence, how you implement persistence. So if you want to implement persistence, you have to implement state, you have to implement the checkpointers, and you have to optionally, if you need multiple instances or multiple user ID, then you need the third ingredient that is thread ID, that what you have to implement. What about the first ingredient? We discussed about this state multiple times in the previous session. State store in a very simple term key value pair for what workflow? It stores key value pair information of workflow. So state stores key value pair of what? Of workflow information. And we also discussed in our previous session that step gets updated at every node or every step. So state contains step 1 output, node 1 output, or step 2 output, node 2 output, step 3 output, node 3 output, so and so forth. But state alone cannot persist across execution. So if this is your process, is definitely state has the information about different node and where the workflow is or where the process is, but it doesn't store something. State exists in memory during the execution only. But once the execution stops, state is lost. So what we need? We need a mechanism to store, and that is check pointer. So state store key value pair of workflow. It gets updated at every node, but it doesn't store. We need something else to store, and that is check pointer. So what check pointers provide? Check pointer provides storage. Because of check pointers, you have snapshot. What snapshot of state? And it also provide the resume capability, restart capability if the workflow breaks or pause or stop. So check pointer, store the states, save the snapshot of the state or save the snapshot of the workflow progress. It maintains a history and it also enable the resume and replay capabilities. So state holds the information, Checkpointers stores the information through snapshot over time, and that is persistence. With these two core ingredients, you can have persistence for one single user. Now comes Thread ID. A lot of information about Thread ID, because Thread ID is used for identifying users, or identify the user in multiple user, or identify the session in multiple session, identify workflow instance in multiple instances. Because when you resume the information, Thread ID helps you inform that which user, or for which user, or for which session, or for which instance you have to resume. Okay. Because in production, we all know that you can have 100 users, 1000 workflow, multiple session. We all know that. So you must know which state belongs to which user, which session, or which workflow. So thread ID act as a primary key. Actually, the right word is it act as a namespace, a session identifier, a user identifier. So what is important to understand? Persistence work even without thread ID in single session or for single user, but for production, multi-user system, or for a production level multi-user application, a process, thread ID becomes essential. So, in a very simple language, if I say state holds the information, check pointer saves or store the information, thread ID identify user, session, or instances. The right user, the right session, or the right instances. And together they create what? Persistence. So, persistence is equal to state plus check pointer plus thread ID if you need multiple session or multiple user. So that is how you create persistence in LangGraph. Please understand what persistence enable. That is important. Persistence enable break and resume. It enables human in the loop. It enable debugging. It enable replay execution. It enable error recovery, versioning, multiple session workflow. And that is why LangGraph is called as or famous as a production ready framework. So persistence is not just a feature. Persistence is the core architecture of LangGraph. And if you understand persistence, you can understand human in the loop, break and resume, debugging, error recovery. Everything becomes easier, which we'll discuss in the upcoming session. So we understand persistence in theory. In the next session, in the next lecture, we'll understand persistence implementation through Python Jupyter Notebook. We already know how to implement the state. In the upcoming lecture, we'll implement checkpointers and thread ID. So we'll build the persistence step by step, because if you understand persistence, you can actually implement any capability, most of the capability of LangGraph, like human in loop, break and resume, debugging, error recovery. With that, I'll pause here and thank you. Have a nice day.